Welcome back to my Asteroids tutorial videos. This is the second video from the first lesson, and in this one we're picking up where we left off. We've got a camera set up and we've got the player ship existing inside of there, and that's about all we did. So in this video what I want to do is actually start giving the player movement. So that means we're going to have to set up the colliders on the player, we have to set up the physics engine on the player, and then learn how to create a script, code the script, and then attach the script to the player. And then look at some of the ways that we can tweak settings from inside the Unity editor instead of inside of Visual Studio. So let's get started. Now, one thing I forgot to really stress on the other video was the importance of saving early and saving often. So you can tell if you haven't saved your project because there's going to be a star next to your project name here at the top. So make sure you go to File, Save. You rarely want to ever use Save As because that'll break the location of your scenes. So it's really recommended not to use Save As, primarily just use Save. Everything else saves, like things that get changed inside of the project are actual files outside of Unity. So changes made to those are instantaneous and permanent. This save is primarily saving our scene, which is really all the changes we've made so far. Alright, so we need to start configuring the player ship. So let's talk about putting some of the components that allow us to have movement and physics on it. So let's start by attaching the physics engine, which is called Rigid Body. The physics engine is called Rigid Body because it actually refers to three-dimensional shapes that are rigid, meaning they cannot deform. So an example of soft body physics would be water. Water changes its actual dimensions and shape as it flows over things. So that would be considered soft body physics. The engine that we're dealing with in Unity is rigid body, meaning the objects do not deform, they stay whatever shape they were, and it does physics with that. So let's add it from the components menu. So make sure you have the player ship selected, because whatever you have selected is going to get this component. So let's go to Components, Physics, Rigid Body. For this project, we're not using anything from the 2D folder, so we just want the ones from here. So once we add Rigid Body, you can see that it shows up on the right side on the inspector. Now, if you accidentally added two of them, well, I guess it doesn't let me add two of them. So we'll talk about that later for something we can't add two of them to. So here's our rigid body settings, and it is a physics simulation, which means it does have a mass. Now, what kind of lets us cheat a little bit about physics is how much drag and angular drag it has. Those are things that modify the velocity, specifically how much, I think per second, it lowers the velocity by. So this has zero drag, which is kind of amusing. It means it's a frictionless object, but that shouldn't affect us too much. We should care about gravity, because for this game, we don't really want to enable gravity. So I'm going to uncheck gravity. Gravity is primarily just used in the sense of it's going to pull you down on the y-axis. So that works great for side-scrollers and first-person shooters, not so great for arcade-style Asteroids games where we float in space indefinitely. Even if you did want to implement gravity of planets or things that if you fly past a planet, it bends your trajectory, that actually is still better handled manually ourselves through code. So this gravity only applies to pulling you down on the y-axis. Is kinematic refers to whether or not it's allowed to move from the physics engine versus through code. So right now we want to leave that unchecked because we could let this get manipulated by the physics engine, even though we probably don't want it to. Interpolation has to do with objects that move extremely fast and may pass through other objects. So if you have like a missile projectile that's traveling so fast that in one frame it's right here, in the next frame it's right here, it actually wouldn't collide with the ship because it essentially is moving so fast that it's teleporting between frames. So that's what interpolation and collision detection are going to handle. Discrete is going to be every frame, and continuous allows it to check in between frames. That's, again, probably a problem we're not going to have in this project. So anyway, what we do care about, though, in rigid body is the constraints. So my Asteroids game is primarily going to be played in a two-dimensional sense, meaning my game is only going to exist in the X and the Z axis. I don't want my player ship like going up. Like, there's no reason for the ship to go up like that. So I am going to freeze the Y position. And I'm also going to freeze the X and Z rotations, because the only rotation I'm going to care about is a Y-axis rotation such as this, such as pushing left or right and your ship turning. We don't have any need for banking or any of these other things. Now, we might eventually decide to put some code in to make it kind of like twist when you're going left or right, but that's going to be something we'll do later, and if we choose to add that, we can unlock those rotations. But for now, let's lock those. Info actually is all read-only values, which is, it's really interesting to watch during playtime, because then you can get an idea of what's happening with all of your different velocity and all that stuff. So that is my rigid body. Let's add a collider. So if we go to Components, Physics, and there's different types of colliders. I'm going to put a box collider on here, even though I don't want this to have a box collider. I'm going to put the box collider on so that we can see it. Oops. So I accidentally added the box camera to the wrong object. I put it on the main camera. The camera has no business having a collider, so I need to remove it by clicking on the triple dots right here and going to Remove Components. So make sure that you have your player ship selected when you go to Component, Physics, Box Collider. So you can see that the box collider creates a hitbox, and the hitboxes are shown in green lines. And it will actually kind of intelligently size the hitbox to the model, to the mesh, as closely as it can. But that's not really how we want to play Asteroids. So a box collider isn't going to really make a whole lot of sense for us. So we actually want to remove it. Now, you might choose to use a box collider or other types of collider like this because they are faster than what we're about to choose. Because we're about to choose a mesh collider, meaning the hitbox is going to be based upon a 3D model, which is a little bit more costly from a CPU computation standpoint. But we want to do it because it's going to make the gameplay feel better, because it's going to be closer to, you know, shots that are near misses will still be near misses rather than hitting some arbitrary square hitbox. So let's switch the mesh, because it's going to default to the standard mesh, which is the model of the ship. And actually that's not a good choice. So if you click the little circle dot over here, it will actually pop up a menu that allows us to look at different other meshes. So you can change a few things about this. If you use this slider right here, you can have it preview the models so you can look at the models, or you can just have it purely as a list. And we can see some of the other choices here. Alternatively, we can also look at them here. But let's go back to my player ship and let's choose this one right here. That's called Player Ship Collider. The reason why why this project even came with a separate collider is that this other one is a lot smaller and simpler on the game engine. So we can see the sample of what the hitbox looks like here versus this one here. And there's in terms of using these for colliders, there's a massive amount of difference between something this complex, which you can see here is consistent of about 2,000 triangles, versus this simplified one, which is about 16 triangles. That's going to have a massive impact on collision computations in terms of the engine. So that's actually why they've made this simplified hitbox for the player. We're not going to use this for the actual appearance of the player. This is just used for detecting collisions. So anyway, make sure that our mesh says player ship collider, not vehicle player ship. Now you'll notice that we still don't have the green lines around the ship. And that's because this is a convex collider. So we have to check the box for that to get the green lines to appear for it to understand that what type of collider it is. So you can then start seeing these green lines. If you turn off the mesh renderer, you should also see the collider. So the mesh renderer is what actually shows the 3D model inside of the game engine. Now, it is worth knowing that if you did disable the 3D model, it still counts as a physics object. It's just an invisible physics object. And then lastly, this other setting here for the mesh collider is trigger. Is trigger, if you look at it, is this collider a trigger? So trigger colliders are a type of collider that doesn't have a physical presence, meaning it's a sensor zone. So it wouldn't bounce off of other colliders. Other colliders could pass through it. If two colliders that are non-triggers hit each other, they will bounce off of each other because they're considered to be solid objects. But if you turn on is trigger, you are no longer considered to be a solid object, which is actually going to be the case for the player. And that's because we don't really want the player bouncing off anything. We don't want him bouncing off asteroids. We don't want the player bouncing off weapons or anything. So I'm going to turn on is trigger. Now the player still interacts in the physics engine, but it doesn't register itself as a solid object. Now our asteroids will probably leave as non-triggers because we want the asteroids to bounce off of each other. But for players, we definitely want to turn that on. Of course, we could see if that doesn't really work out in terms of how we start coding it, that plan may change. And so now we've got this all set up on the player. So let's start making a script to talk about, or to start setting up movement for the player. So we want to create a new folder because we want to try to keep our scripts as organized as possible. So right click on assets and go to create folder. I'm going to call this scripts. And then because I want to plan ahead a little bit, I know that I'm going to have a lot of scripts for this game. I'm going to make another subfolder inside of the scripts folder called player, because I'm likely to branch off the player's movement script from the player's shooting script, just to kind of organize things. So I have a subfolder here on the scripts for player. So right click on player and go to create C# script. Once you click on that, you will have to type in a name. And it's very important that you don't hit enter early, because this first naming of the script actually changes the name of the class inside the file. So if you were to rename it later, you might run into a little bit of trouble, meaning you're going to have to modify the C# file itself. So the first attempt at naming the script is the most important for giving it its name. And this follows the standard rules of naming classes that we've learned about in C# and in Java, that most specifically for us, no spaces. So you cannot have any spaces in the name of this script. So I'm going to just call this player ship. No spaces. But I am using camel case to make it easier to read. And then I push enter, and it commits the script to being named that. So then double click the script, and Visual Studio will open. And we can now see our player script. We're not going to use this attach to Unity button, although Visual Studio will detect any inconsistencies with how it's programmed with the names of the Unity methods. So for instance, you can see that this mono behavior class is turning blue as if it's a keyword, because it is a keyword in the Unity engine. So if your mono behavior is turning blue like this, that means that Visual Studio has properly detected the Unity names of its methods and such. All right, so we have our script open and we're going to start working on it. So the first thing I want to point out is the methods that it gave us to start. It gave us a start method and an update method. Now there's a comment here that describes what it does, and start is basically the first method that gets called before the first frame. So start only happens once, and this kind of serves as our constructor for the object, since we don't want to use a traditional constructor to set things up, because that may not mean the ship is instantiated in the world yet, even if the class is created. And then update, we're going to talk about that in a second. So let's focus on getting the initial things configured. So keep in mind we have our instance variables, and we're going to have a couple of them here. Let me set up a few for movement. So our first movement variables I'm going to create are going to be some variables to handle the move speed and turn speed. Now the Unity engine primarily only deals in floats and integers, so we're not going to be using doubles here, which does lead us to another kind of issue here. You can see that if I type in 32.0, it actually thinks that this is a double. You can even tell from my mouse over that it says double. But like I said, the Unity engine only deals in floats. I think partly because this is 32-bit computations versus 64-bit. So most of our decimal numbers are going to be followed with an F at the end to essentially cast them to the float data type. And this is going to ultimately be measured as, I want to say, units per second, although it may not end up working out like that, because if we treat this as an acceleration, it may not truly be a units per second. We're going to start with that number. And so then we have a turn speed. We're going to use these as variables that allow us to tweak the speed of the ship so that we can adjust it for whatever feels best when we're playing it. And you'll notice that I made these public variables. And that's because public variables will show up in the Unity editor for us to change. There's going to be another style of doing this that I'll bring up later. But for now, you can just kind of know that if it's public, then it will be seen in the editor. So now I'm going to do some of my behind the scenes variables. We're going to create a ship variable because this represents the physics component of the ship. So it's a rigid body type, meaning this is going to be where we're going to perform all of my movements, my rotations. We're just going to say ship dot move or ship dot rotate, because moving and rotating, we want to handle that in a physics sense. And I'm going to make variables to keep track of the keys that I've been pressing. So my vertical inputs, like my W and S up and down input, and then my horizontal, my left and right. And so that's all we need right now. And then we're going to actually go through and start tweaking these. So something to keep in mind is whenever you change your code, Unity is not going to know you've changed it until you've hit save. You can tell unsaved changes are yellow along the side here in Visual Studio. So whenever I hit save, it updates and commits those changes, and actually Unity recompiles the script, and you can actually see that if I switch it over to the console view, it does give me some of its own compiler warnings. Now, keep in mind, warnings are not a bad thing. You can see that it's really just saying this variable is assigned, but its value is never used. So it's just saying, hey, you're wasting a variable here. If it has a red stop sign looking exclamation mark, that's a error, and that needs to be fixed before Unity will compile again. Keep in mind a few other things. If I change the name of my class, like I put a 2 at the end of it, and I hit save, we're going to get an error over here in Unity. Well, I guess if I tried to attach it, it probably would. So I've got a problem with my script at that point because I ended up renaming it. And that's a really deceptive error to fix. Knowing that I changed the name of the script here, but that change has not been reflected in Unity. So for example, if you are going to rename your script, you're going to want to make those changes and save, and then rename it here. But then that's going to require you to redouble click it, because Visual Studio will think that it's a different file now. So that's why I was very cautious about warning you about what you name your scripts initially. So try to get them named right on the first try. Otherwise, it's a little bit of a hassle to rename them. All right, so let's take a look at stuff that we want to do during the first frame call. So we want to attach my ship rigid body to the actual component. So right now, from what we know about programming, ship is null because it hasn't been instantiated or hasn't been assigned yet. So let's say ship equals get components, and then we use the angle brackets and we specify the component that we're getting. You can actually specify like literally any component that exists in Unity inside of here, but I want to get the rigid body component. And so what this command does is this will link, well, as Unity compiles the script, that will link this rigid body component to my code area. So all the changes and stuff that we see here is now going to be shared in Visual Studio. It's a very important link to do. So let's begin programming. Let's get some movement going. So update, there are two different types of update methods. So we've got update and we've got fixed update. Update is called every frame, but fixed update is called every, I believe it's called every 0.02 seconds. At least it tries to call it every 0.20 seconds, but it has a fixed time in between every call. And this is for your physics stuff. So anything pertaining to specific physics interactions need to be done inside of fixed update. But anything done inside of update, any sort of movement gathering or input gathering, needs to happen inside of update. Because if like let's say we try to record attacking, if I press the mouse button but I try to gather it inside of fixed update, it may skip over that event because this is not correlated to frame draws. So you actually want to gather all of your input inside of update. Anything that pertains to physics needs to happen inside of fixed update. And so that is at first a little bit weird distinction, but it's an important distinction to know that that's actually how you need to treat this. So we're going to gather my input inside of update, and then any of that has to do with physics, which in this case moving and rotating, both of them, will need to happen inside of fixed update. So update, let's get my keyboard input. So I'm going to gather my vertical input. So I'm going to access the input library by typing input and then pushing dots. And you can see that there's a lot of different choices here. We are going to use a lot of them, such as get button down, get button up, and get button. We'll talk about those when we start getting to fire effects. But right now we want the get axis. Get axis refers to controls that are essentially pre-bound for us. So like if you push up or back. And let's go get the horizontal one as well. I do want to point out that we don't want to use the get key command because you can see there's a get key. If we were to use get key, we're basically tying that input to only the key that we've defined in code, and that's not how you want to program a game. You want the user to either use a joystick or a keyboard. You want them to be able to redefine their controls. All right, so that's going to be my input gathering. Now, to see where these names are coming from, vertical and horizontal, and let's hit save. That's actually coming from my project, edit project settings, and coming from inside of the, it should be input, I think, axes. Yeah, it is input manager, and then you expand the axes menu, and you can see that this is actually the horizontal axis is defined. It gives it its name here. The negative is the left key, the positive is the right key. There's your A and D, and so that's the horizontal axis. But there's another horizontal axis down here that's actually your joystick, and since they have the same name, they both get pulled whenever I say get axis horizontal. So it's reading both of those and essentially doing an OR operator on the inputs from those. And so vertical is here. You can create your own axes, whatever. There should be an option right somewhere. Oh, I have to. If I expand the size of the array from 18 to 19, I could create my own axis and then give it a name and give it a keyboard association. So like I can make an axis called float that might refer to moving up and down and make that my Q and E key. So you can create your own axes for movement. That could be a useful thing to do. And you can even see that like your fire 1 is considered to be a button. It's a mouse button or left control. So we'll be dealing with that later. All right, so back to my input. So we've gathered my input. Now let's actually use that input. Like I said, we don't want to handle physics stuff inside of update, so we want to handle it inside of fixed update. So then we only want to really run this command if the keys are being pressed. So we say if input V is not equal to 0. Now, I suppose you can make the argument that you might need to like do a check within a threshold of movement. So you could do like this, like maybe that way like small amounts of if the joystick is just slightly pressed, it doesn't count as actually being movement. So something to keep in mind is that if you wanted to have like a dead zone type of effect on your joystick. So if we're pushing the forward key, let's do the code to move my ship forward. So that involves first getting my actual location. So we're going to say vector3 current position, and then to access my current position we say lowercase t transform dot position. The transform is actually auto-binded to this right here. All of this stuff inside of this transform is what pops up whenever I get this. So current position transform, and then we can do dot position. You notice that there's also like rotation and scale and stuff. But we want to get my position. So we're getting my current position and storing it in what's called a vector3. And all that really just means is it's an XYZ value. So it means vector3 in Unity means both a point and also a vector. So it just depends on the context it's being used. Right now I'm getting it as an XYZ position. Then we're going to make another vector3 for the direction that I want to move. I'm calling it move direction, and I have to get the forward. So I'm going to say transform.forward. And some extra commands on here. So quick explanation of some of this. So this is determining how far I want to move. So I want to move in the forward direction times how much I'm actually pushing the key. And I actually probably need to put my move speed in here. Times my move speed times time.delta time. So the idea is I get the forward vector, and this is a unit vector. So if you want to think about the math that's happening here, the forward vector is kind of like this. It's in a scale of 1. And then the input v is going to either be -1 or 1. -1 if you're pushing back, 1 if you're pushing forward, times my move speed, which I think I set it to like 32, times time.delta time, which in this case, because we're within fixed update, is 0.2. So this is actually the mathematical computation that we're doing here. What the importance of all of this is, most specifically the move speed times time delta time, what that does is it adjusts my move speed to be relative to the frames, in a sense of relative to the seconds that's passing in each frame. If you didn't include delta time, what ends up happening is your move speed of your ship becomes dependent on the frame rate of your game, which would make absolutely no sense. If you had a faster computer, your ship would move faster than other players' ships would. And so that would definitely not make any sense. So that's what's happening here with this move direction. We're computing a vector, and we're multiplying it by a bunch of scalars to actually consider what length that vector needs to be. Then we'll make the move. We will say ship.move position, current position, plus the move direction. And then optionally, we can clear out my input buffer, and this is only if it gets stuck moving forward due to frame rate issues. So we probably won't need that command, but in case we do. And so this is going to move me, it's going to do a physics-based move, because you can see that move position is a rigid body action. It's going to move me to a certain XYZ position. It's going to take my current location and add my movement vector to it to calculate a new XYZ position to move me to. And we can hit save, and we can see this work. So if you hit minimize, we can attach this script to the player by dragging and dropping this player ship script onto the player ship. If you have no compile errors, it will happily attach itself as a new component, and we can see it listed here. And if we hit play, we should be able to push forward and back and have my ship move forward and back. I don't have my rotations in yet, and this looks kind of fast. We'll deal with that in a second. But we have my movement working. And a quick thing to note, though, about what's considered to be forward. Inside of the Unity editor, be mindful of what setting you have your tools on if they're local versus global. When it's set to local, this axis reflects what's considered to be forward of the ship, even if it's rotated. So let's say my ship is rotated like that. You can see that it's showing forward to be right here. But if I were to switch this over to global, you can see that it's showing the axes in a global space. This is positive z in the world versus positive z for this ship. And this move command that I did, this move command is actually moving me relative to the ship because I'm using my ship's forward vector. And so that's how it knows which way forward is. So I recommend leaving this tool on local for most things. All right, and let's get rotating, and then we will be done with this set of instructions. So, next part is going to look very similar. If my horizontal movement is not equal to 0. Now, rotations are not based in a vector space. Rotations are actually stored as a data structure called a quaternion. And a quaternion is essentially rotational information. There's a lot of math behind it that most game programmers don't need to know. And it's essentially like a 4-dimensional storage for rotations, and it prevents the rotations from looking bad, is ultimately why they choose to use the Quaternion to store rotation information in. Unfortunately for the developer, that does kind of lead to some confusing commands. But let's take a look at it, and it shouldn't seem that confusing. So let's create a Quaternion called my current rotation, and we're going to pull it from my ship. I'm going to get my current rotation. I probably could have just pulled it from my transform as well. And then we're going to then create a Quaternion for how much we want to rotate. So I create a Quaternion called rotation amounts that I'm going to build. So Quaternion.Euler angle. Well, let's do Euler. And we only want to rotate in the y-axis. So you can see that this Euler method is going to build a Quaternion out of 3 different inputs. I only want to rotate on the y-axis. So I'm going to essentially mimic this concept here by putting in my horizontal movement amount times my turn speed times time.delta time. And then we're going to put the z rotation there. So this constructs how much should I turn. So we've got my current rotation, and then how much should I be turning. And so we're going to then rotate the ship by doing ship.move rotation. So it's very symmetrical to how we were doing this other one. And Quaternions do their magic through multiplication. So if I have my current rotation multiplied by my rotation amounts. And then again, if you have some weird kind of stuttering issue, you may need this other command of clearing out the input. So let's see how this looks. Remember to hit save on your code. And then we're going to pull up my Unity as soon as I can actually get it open. All right, so this script should have updated, and we do not need to reattach it, so make sure that you only have 1 copy of the script on the player. Hit play, and now you can see that my ship is able to spin and rotate, and then if I push a key, it rather crazily gets off the screen pretty quickly. So we can see that my controls are a little too fast. And so let's tweak those. Now, you can change them right here inside of this script view. So we can try dropping my move speed to about 12 and my turn speed to maybe about 200, and then hitting play. And you can see that that does have an immediate impact in how my ship moves and feels. But you can also change them permanently inside of the code. Notice how these variables didn't change. So let's say I wanted to, let's set these back to normal. These were what, 12, 60, 36, and 300? So let's say I wanted to change it inside of the code. If I change them here and make my changes like that, and then I hit save, what you'll notice is back inside of Unity, those values didn't update. They're still the old values that I made when I first created the script. However, if I right-click the script and tell it to reset, it will actually re-pull those values back from the code. So if you change the values, it grabs those values when you first pull it from the code, and then if you change them, it's independent of what you change them in the code until you hit reset. And so you can see that this gives me a much better type of movement for my ship. And so we'll stop here. I'm going to include some extra videos if you're interested in doing mouse control, as well as some other types of movement. If you wanted to replicate more of a a force and momentum style of movement. So thank you for watching.